Okay, there was a quick question I saw on one of the controller forums about not being able to use the debugger, not being very confident in using one. Actually, on reflection, look at my earlier video, and we're looking at the scripts directory. So we pulled down a controller, we've set the time base to the one suggested by Archangel, and we've made our build. And let's just have a look. I used gvim. What did I do differently? Well, the first thing to look at here as we scroll down, let's go to the end like we did before. So it detects the OS. In my case, it thinks it's Linux, and it does the build now. So we use the hash key, pound key, whatever you want to call it here, and that will go backwards. And it finds the build now, and we're in build now Linux. So use the hash key again, and it drops you to there. Um, and what did I change? Here we go. Look, shooking remove later. So these are the sort of things I tend to put on. The first thing I said is don't remove the binaries you've just built. Now, if you want to do this, you should use a clean step, yeah. But the idea here is that the code, the makefile, will do the right thing and build the right things anyway. Removing these libraries is a little bit of a unnecessary step. And in some cases, you might want to make a simple change and most of the code is good. But, you know, this pays your money, takes your choice. This should be okay if you don't do that. But I just don't remove it. So what else? Here we go. This is interesting. So I don't build the VST. The VST doesn't build, and I'm using stuff standalone. So I get rid of that. So you need this little hash gets rid of it. Hash is a comment, and any line that's part of it. So this one just tells you to go to a place, run a shell, and this one says if blah blah blah. So this is one statement, two statement, and then a block of statements, and we just make certain there's a comment in front of them. The most important thing when it comes to debugging, for God's sake, don't remove the strip. Um, when you build a program, the compiler creates symbol tables, and stripping these symbols is really, really bad if you want to understand what's going on in the program. So what I do is I say to okay, hash again, put the hash in front of it. And just in case you're not certain, what you do is you go to a line and you do I for insert, and then you push the hash key, and then you push escape to get out of that mode. In this case, X to go back one, but that's basically you'll use Nano or some text editor, but just put a comment in front. Um, Also, it's a good idea. I don't know if I've actually done it, probably because I'm hardcore. It's a good idea to copy post commit to post commit dot orig, say, before you make any changes. And if you screw up, then you can just basically uh, copy post commit orig to post commit. Now I've done that whilst this is editing and it will get upset, but that's okay. We'll load the file. But that's the idea. So put it to one side and then mess with it. And if you screw up, go back to the beginning and start again. If you're really disciplined, use a Git or some source control version. Anyway, so we comment out the VST build, we comment out the strip, and we comment out the strip here. And I think that's most, and then we do it again down here, look, because there's a later stage here where it does the strip, and then you're good. And then I comment out this bit here down below. Maybe I should put some line numbers on. Set number. So around line 350 at the time that I put the code back, we don't want to SCP this to Atom's repository. It won't let us anyway. We don't want to do it. It's kind of silly. You could just remove it. The reason I comment it is to allow me to put it back in, although I don't need it yet. So that's basically the first stage. Inside the post commit shell, comment out all of the things that are going to cause grief. And so in my case, this is here, lines 2. Well, that's an extra line gone in now, hasn't it? So it would have been old line 282, 283. Because that's gone, and then it would have been old line 309, 310, 311, 12, 13, 14, 17, 18, 19, 20, 22, 23, 24. That is the first stage. This program we saw calls a build script. So let's actually get to the build script. We want the build script, which I think is this one here. Yeah. So this is found in your tilde, so wherever you put it. So here we was in Documents, Software Controller, Scripts. So it would be up a directory to get us to there, and then down 1, 2, 3, 4 into this builds generated Linux standalone. And here, when we look here, we've got the libibities that we copied across the ARM versions of them. And then we've got a build.shell and a makefile. And if you recall from the earlier video, the makefile is linked. Actually, it was linked. I don't know if it still is. Sorry, the build is linked, isn't it? Maybe I unlinked it. I think I unlinked it for a reason. I'm not exactly sure why. Anyway, let's look in the build.shell. So let's use the vim build.shell. We go to the top, 1G. So what we did is we said use 4 processors on the Raspberry Pi 4. We added in the extra directory here, and now look here again, more shooking stuff. So I don't bother removing all of the build stuff. The stuff will get rebuilt by the compilation, and actually I prefer to use a make clean at this point as a conscious decision rather than arbitrarily doing it for you. Now here's the kinky thing. It used to say release nightly. And what you do is you copy that line. So in this case, would Vim, you would do a Shift Y for a capital Y to yank, and then Shift P to paste, and then you would insert I a hash, and that makes it a comment. Then you would move along a word www, a few words, and you would change word CW to release underbar night and then escape, and that would do it. Okay, so what we did, we copied the existing because Atom wants to build the release, the fastest possible version, but we want to debug. We want to find out why it crashes or make changes. So change it to debug. And we didn't strip the binary either, so now the symbol should be there. So now let's have a look at Cubang that. You would X if you're saving I'm Cubang, I want to get rid of the changes, yeah. So now we look at the makefile. Sorry, yeah, it is makefile. And we had to do a couple of things in here. I think we had to add some flags on. So for the later version, we had to add on, wasn't it something round or something? Let's have a look, /round. Yeah, that one. have round. So we changed that, if you look at the earlier video, so that we pick up the juice round, because the C++ 11 has changed the standard. Although there are a few warnings in the build about various function prototypes changing, and that worries me slightly because, I mean, first of all, the auto pointer is going to go fail. Well, I hate auto pointers anyway, they're kind of dumb. And secondly, there are some other things that are going to go wrong, yeah, in the future. But you know, Atom is working on later builds, and at one point, hopefully, he'll describe how to build the later build. This is to build a 5.3 target. So Ctrlr debug is the target coming out. So when you've built that, you should end up it puts it in packaging, and then it puts it under Linux, I think it is, and then it puts it under controller, and you end up with this thing here. And so now what you would do is run your GDB. So GDB dot slash, because it's not in the path, dot slash controller debug, and now you're in a standard GNU GDB, and you can look things up online about it, but let's just go through some basic stuff, yeah. Because the idea is you want to catch if things are going badly wrong. And what I'll show you is something where, hopefully I'll show you something went wrong. So at this point, it's finished reading the symbols in. So if you did the strip and if you left the commands as they are, the strip has come in, you see nothing. Let's just actually go to that place. Hang on, bear with me. So where did it put it? It put it under packaging, wasn't it? Linux controller, and we have the binary. There's a really nice command under Unix nm, which is name the symbols, yeah, and there's various things you can do, but let's just do the simple version. So nm dot slash controller debug, and this will take a while and go through all the symbols it can find in the program. When you strip stuff, this is removed, and this is removed to make it harder to reverse engineer what's going on in the code, yeah, for obvious reason. But here you see we get this kind of crazy version. So if we do nm -- help, it will tell us about the demangle style. So -c or -- demangle and GNU v3. So let's just grab that, Same command, minus dmangle mangle even equals middle button. Yep, was that dmangle equals? Yeah, look, minus dmangle equals style. And we'll put this into more. So what? Ah, yeah, okay. Would help if I gave it something to look at, wouldn't it? That's fair enough. So I forgot to give it the binary name. Of course, it's never going to find anything. Yeah, that's fair enough. So now you see what it's done is it's changed the format. We'll see one in a moment. It's tried to add in extra information rather than this sort of, I don't know, sort of signature format. So when we get to some C++, this is all C, and I think F is function, and T is text and whatever. So here we should see some information. Those are the globals. Forget that. Now, if you strip, you won't see much of this. It's all gone. We could probably do it to prove it, but just trust me. So somewhere we should start to see some more information, which will be more C++. But there we are, look. So now we've got the colon. So this will give you the names of the methods or whatever. In this case, it's a guard variable, but the names of the specific functions that are used in the binary. And that's what the debugger is doing. It's looking up these symbols and saying, okay, what do you want me to do with them? And so when you get a lot of these things that are the same, it means that there's a bit of polymorphism going on a template or something. And so you might have to be a bit more specific about which one you want to break in. But you get the idea. By using the dmangle, you can see what's going on. And, oh, ZX81s. And you also haven't actually stripped the information out. So the debugger comes in and reads and says, hi, here you are. So now you can say info signals, I think it is. And this tells you that hang up is call and pass to the program, interrupt is not. I mean, there's certain things like sigkill you can never actually trap those by definition. They go straight through. But this is the main thing, segmentation fault. So this is 6egv is caught and will stop the program if something goes wrong. Yeah. If this was switched off, then it doesn't stop, and what will happen is you'll crash and you'll be none the wiser. So now what we can do, we can run. We haven't set any breakpoints, so info breakpoints. So we could break in main, yeah, and that will stop when the program hits main. We could break in controller panel controller panel. So this is breaking in the constructor of controller panel. Yep. And if we do a list breakpoints, it will tell us which ones we've got set. Yeah. Breakpoints. Info breakpoints even. You kind of just type this stuff, and when you have to describe it, it doesn't seem to work. So there we are. It says that there's multiple places it's going to stop. Yeah. And this even tells us where in the code. So what's quite nifty is to actually open some of this stuff. So for example here, we'll pick that up like so, enter, and we will vim that file. Yeah. Oh, what did I do wrong? Hang on. Push directory. Hang on. Push directory, which means leave it on a stack. Up 1, 2, 3, controller. Where's it going to be? Juice. Yeah. Modules. Yeah. J tab. Events tab. Messages. Yep. Juice. Okay, we'll go there. Vim. JUCE underbar applications .cpp, and if we say :208, it takes the line. So this is where the main is going to be called, yeah. And we're not on a Mac, we're not iOS, so I think we're going to go in here. :set number line 218. That's my prediction. So now we say run, and the program starts. And now we're debugging. We've got the symbols in loaded, and if it crashes, so it stopped at line 140 of controller standalone. So actually we can we edit that thing? Let's see if we can do this. Edit, copy, edit, paste. Yeah. So what we did do, we use the :E of the Vim to move between it, and it says it's line 140. So 140 go. So we're here. Start juice application. Interesting. But that seems to be outside of the. Now let's push the hash key, which will search. No, I don't know. I'd have to search through the code for that. And actually, another neat trick. There are better things. The oxygen is quite cool. /documents/software, our controller. Um, let's go to the source level because that's going to be the right place. So we can do grep -r for start juice application in anything, and it should go through and see where it found it, and it finds it there in standard controller. That seems to be the same place. Let's just see Control G. Yeah, so this somehow must be passed in from elsewhere. I don't see. Hang on. Find start. I don't see where it's defined. Yeah, must be inside. If it was defined in the program, I'd expect to see it. But anyway, it doesn't matter. I don't understand why it stopped there. So N move to the next. N will move to the next. And if you keep pushing enter, you do the same thing. But this would be really tedious to go through the program like this because one, you don't know how it works, and two, it could take a long time. But if you have the time, it's great. So now what happens is the program starts in the background, and you see it's beginning to initialize here. And what we can do to save a lot of boredom is to say C for continue. And so this will carry on, and it will hit the next breakpoint, and we hit breakpoint 2. Okay, so info breakpoints tells us that we're currently at 2, and there's a number of them here. So it's at line 30 or line 65. And actually, if you do list, it shows you the code around where you are. So that's we're just basically setting up the panel editor, the output devices, the undo managers, and that. So again, we can do next, or in fact, better, we can do control as continue, and we'll keep going. And now we got to a thread where the program is now started a new thread. It's multi-threaded, and it's running around doing its thing. Yeah. So let's open up one of my panels that normally causes a problem. This K1, and the reason is it was built on a Windows box with what f:/synths or whatever as a path. That doesn't exist on a Linux box. So when we do this, we may begin to see where it gets upset, but let's have a look. There. So now you see it says no such file. Now, to be fair, I'm not really certain how you can get it. So it's called a trap, yeah? Assertion failure juice file CPP. So what we can do, we can go up to here. We're in the source. So this is juice. So we go into the juice. And no, we go into, it's juice. No, juice modules. I didn't see it, sorry. And now we can find dot minus name dot juice underbar file dot cpp minus print. This should find that file there. So we can vim this file, that one, middle button, and it tells us it's line 138, so :138, and here we are. So where are we? So what you do, if you're at this point, what you can do is you can push on Vim the double open curly brace, which is the one above the square bracket. So shift, boof, boof, do it twice. It should take you, oh, sorry, 138 go. No, 138 go. There. Sorry, you just push the square bracket twice, and it takes you to the beginning of the file. Actually, what you can do is quite neat. Should work. Set fold method equals indent, and now you get a slightly different version, and we go to 138 go, and we see as we move up a condensed version of the function. It's much easier to read. So this is parse absolute file. If it's empty, come back. If it's juice Windows, no, we're not on Windows, but you see we were on Windows, and that was going to replace the forward slash with a backslash. Okay, I think that's what it's doing. We'd have to look up that to check. And if it's got a dot dot, then move up a directory. Yeah. But now it says Mac or Linux. Well, this panel was created on Windows, like we said, but now we've moved it to Linux. So now we're screwed with this logic. Because how can it possibly find this? Because it's not on Windows, yeah? But, well, that was our bad. It's not Atom's fault or whoever created it. It's our bad. We moved the panel between versions. So they say it's known for that, but it's essentially try and catch you trying to run code written on Windows to hard-coded path names. So here you go. So someone's trying to catch that very, very thing, yeah? And it's trying to say, hey, guy, do you realize, yeah? And then you'd have to go and edit your panel. And we hit this assertion that it starts with that or what have you. Now, I think I had to change the build slightly because normally what would happen is this would actually crash at this point. I think it throws an assertion in a destructor, and that's a pretty bad thing to do in C++. But so let's carry on. Next, where are we? And you see now we see we're at line 140. So let's put this colon set number. So now we're at line 140 here, out by one. Next. Oh, sorry, next. If path contains that. So it's trying to check the stuff, and the assertion fires again, yeah? And it fired a sig trap, okay? Now again, without a debugger, you might hit something like this, and then it will crash, yeah? But now you can say C to continue, and you see somewhere it will show us here. Oh, I saw it and then I lost it. There, look. So you see, I used to have it, this panel lives on F colon slash. And I think until I made some change, this would crash. So I believe I had to change this code slightly to allow it to not crash. But this is where the debugger is useful because it will show you stuff. So basically, that's how you use the debugger, or one way to use the debugger to try and capture stuff. And then, of course, you can begin to look around the source code. And there are various ways you could do this, whether you load it into code blocks or whatever, or Microsoft hardcore. I like old style Linux command line, so I just use that. Or you could use a nice program called S Navigator, which I might show at a later date. And that's a pretty cool way of moving around. But yeah, that's basically what you do with the debugger to find out what's going on. And then you can use that in the forum to say, hey, I noticed at line X. And oh, yeah, um, maybe let's close this and get that to happen again. Yeah, so sorry, let's close that. Yeah, and let's get it to trigger that assertion again. Open recent. There we go. So we expect to hit C for continue. We expect to hit that assertion. There we are. And so what you can do is to say where. And this is really helpful for debugging, the first part at least, the first few. So this tells us we hit a kill in parse absolute file. And so grabbing this sort of information at least down a while is helpful to people who are trying to help you. So they can look at it and say, oh, wait a minute, let's have a... What's also really helpful is knowing what version of the code you use, but that's a bit tricky, yeah, because obviously things can move on Git. But at the very least, here you'd be able to see from this that the parse absolute file in the file 138. So what you would look at if the code is on a more modern version, you'd look around that file and try and see, can you find an assertion in there? And the line may have moved a bit because of code change, and then you might be able to get an idea. But this gives us some idea at least what's going on. So hopefully you can build your version of controller, run it through a debugger like this, and when you get your problem, get the where. Make certain you don't strip the symbols. Get your where and report that. Oh, change to build a debug, not a release version, and then get the where, and people might be able to help you a bit more. So hopefully you find that useful. Okay, cheers, bye.